learning about the regression for today. That is the second topic for the module 4. Second topic for the module 4. Okay. So, what are the concepts we have learned in decision tree? Can anybody just say what and all we have learned in the last week? What are the topics we have learned last week? Can we just have a gist of it? At least the topics. You can talk to me. Even if you're making mistake, we are all here to make ourselves correct, isn't it? What and all we have learned? Tell me. Decision tree concept. Okay, decision tree definition. Why decision tree? What is decision tree? Where do we normally use the decision tree? Okay, next. What are the other topics? So, no one is interested to answer to my question. I'm talking to you. Okay, so what is the course outcome, course objective, what we are learning here? We are learning data mining techniques, isn't it? And that too, what we have categorized as supervised data mining, unsupervised learning in data mining. And initially we are talking to you, we are learning, okay, supervised learning techniques, okay, supervised learning techniques. Then we will learn unsupervised learning techniques, right? So in that sense, we started understanding the core data mining techniques from last week, okay? So that is the objective, and the outcome is we have to make use of these techniques where we can apply, in which application we can apply, and how do we test ourselves and validate with the sample data sets, that what are the outcomes and the resultants of these algorithms based on the data mining techniques, what we are learning, and applicable for the different domains and the realistic applications. Okay. So let me share the presentation for today's class, that is regression. Okay. Oh, 1 minute. This may not. Okay, 1 minute. Give me a minute time. Okay. Let me try sharing it once again. Give me a minute time. Okay, let me try once again, because it is the old presentation which is trying to open, but I need to get the modified presentation for the regression topic. Let me get it from the desktop. Okay. Fine. Is the presentation visible to all of you? Is the presentation visible to all of you? Presentation is visible to all of you? Okay. So as the course outcome and we were discussing, like we are inferring the different core data mining techniques and its applications where we can apply. But the lesson objectives I'm talking to you now, because we are starting a new chapter, the new lesson on the new topic for the data mining technique called as regression. So there are five learning objectives of this particular topic, regression. So we need to understand the basic concept of correlation and regression. And we need to learn how to do the regression exercises, like what we have done it in the decision tree also. Learn how to do a non-linear regression exercise, because there are different types of regressions which I'm going to discuss with you in the consecutive classes, or today itself if time permits. And we are going to learn how to do a non-linear regression exercise. Okay, and we will also learn to know about the logistic regression as a technique for classification, and finally we'll see what are the advantages and disadvantages of the regression. Okay. So these are the learning objectives of the lesson regression. Fine. So now let me make it as a full screen. Is it the presentation visible to you properly, or let me make it full screen? I'm asking you. Is the presentation clearly visible, or can I make it as a full screen? Please answer.
It's visible, ma'am.
Okay, fine. It's visible. Thanks. Please quickly respond. Otherwise, it will be a wasting of time for both of us. Fine. Okay. So the objectives we have seen. Okay. There are 5 objectives which we are going to learn in this whole topic. Okay. So let us see what is this regression is about. Okay. So as I mentioned, it is as similarly very important like our decision tree. Okay, like our decision tree concept, what we have learned so far in the last week, in the last lesson. Okay, so regression is also a very much well-known statistical technique to model the predictive relationship between lot of information, but there we were never segregated the information or the data. Okay, but here we are going to talk about, we are going to build a model, we are going to define a predictive relationship between the two variables or several variables. Then the question comes, ma'am, what is this variable? Let us see this. Okay, so there are different variables in a data set. One might be dependent, one might be independent, or n number might be independent, but dependent will be always one. Please underline this. Why is it? We will see with lot of examples, explanations. Okay, so we are trying to use this technique, which is a well-known statistical technique. So regression is a well-known statistical technique which is helping us to model the predictive relationship between several independent variables, and one dependent variable. And the main objective is of the regression is to find the best fitting curve. So Up to now, we have seen the graph, we have seen a line graph chart and all, but when we have seen the charts, we have come across a lot of dots also in it, isn't it? So the main objective is to fit a best curve in our axis, x and y axis. But we don't know what is x, what is y. So we are trying to derive that, whether x is a dependent variable and y is an independent variable, or x is an independent variable or y is an dependent variable. So the objective of the regression is to fit the best fitting curve for a dependent variable in a multi-dimensionality space. So for each of these kind of independent variables which are being considered as the dimensions, so we're going to plot the points and we're going to draw the curve. So the curve could be a straight line. It need not be necessary. The name itself says that curve means it should be an irregular shape. So curve could be a straight line or it could be a non-linear curve. That's why the regression is further divided into different types of regressions. The linear regression, non-linear regression, logistic regression, like this. So we will see one by one in depth. The curve, whatever the curve could be a straight line, what I said, and it could be a non-linear also. But when we draw the straight line by joining all those dots or all those points, okay, the quality of the fit of the curve to the data can be measured by one of the measuring parameter called as coefficient of correlation. Coefficient of correlation. So this coefficient of correlation, we normally mathematically represent it as a small r. Okay, mathematically we represent it as a small r. Okay, and the small r is trying to be derived with a definition as the square root of the amount of variance which will be explained by that particular curve, what we are trying to. Next, the thing we need to understand is what are the key steps in the regression? What are the key steps or the number of steps which are supposed to be followed or adopted when I'm trying to do the regressive statistical analysis or the statistical analysis using regression as a technique in data mining application. So the very first step to be followed is, but actually all the steps are very simple. So we need to list all the variables available for making this model. Whatever the available variables are there, so we need to list all the variables available before we try to construct or make this particular model. Then we try to establish only one, so that is one dependent variable which is being abbreviated as dv of interest. So establish a dependent variable dv of the interest. The third step is we need to examine, okay, we need to examine if possible the visualized relationship between the variables of the interest. So we need to examine the visualized, through visually we need to see the possible relationship between the variables of the interest, and finally we need to find the way to predict the dependent variable using the other variables. The other variables are independent variables. Okay, so let us take an example. Okay, so the what kind of a data driven or the data information or the predictions which will happen in a market. Okay, so let us take an example as per the given content. Okay, so the traditionally we know that whenever we try to get an election, so the scenario is an election actually. So the traditional pollsters so still seem to be understanding what kind of the methodologies which will work well in a decade or two. So it's a kind of an election oriented predictive market information, which is data driven prediction market information. Okay, so there is data which is being based on the political forecasting who are being seeped in the big data and advanced data analytics. So it is almost 1 decade back data. So in 2012 elections, where the person, Nate Silver, he is called as a competent person who was competing in the election. Okay, so he predicted that Obama would win the election with 291 electoral votes compared to 247 of the other competent called as Romney. Okay, so they're giving the president as 62% lead and re-election, and he was being very stunned to listen to this or know this information. about the political forecasting the world by correctly predicting the presidential winner in all the 50 states, which were including all the nine the states also, the swing nine states. And it was also being predicted as the winner in 31 of 33 US Senate races. So it was being predicted by the model. And the person who got this is the Nate Silver, who brings the new view to the world of forecasting the political elections. Viewing is as a scientific discipline. So he bought this actually, the state of hypothesis, scientifically, which is collecting all the information, analyze the data, extract the insight, the metadata using very sophisticated models and the algorithms, and finally apply this judgment to interpret that those insights. So we need to apply this to dig into that, and we need to conclude it with what kind of the results are likely to be much more grounded and successful. So these are the informations which are being picked up by the source called as the signal and the noise, why most predictions fail but some don't, by the person, by the author, or by the researcher called as Nate Silver in 2012. And the question which was being asked or raised by this kind of a research, what is the impact of this story, whatever the story I just narrated as a US election in 2012, about the prediction of the president, the Obama and Romney, in between two people. So what is the impact of the story on the traditional polling or pollsters and commentators? So this is the question which was being asked and tried to address also. Okay. The next thing is when we say that correlation. So we said that we need to, in the introduction only, we said that we need to try to see the correlation. So I said mathematically we try to define the correlation as small r also I said. So let us see in depth what does this correlation means in the relationship means in between the variables of interest, that is the dependent variable and the independent variable. So the statistical relationships are nothing but, or it is about the elements of the data, which is together and which hang together, and once which does not hang, means once they connect to each other, and once it is very separately kept. So it is all about the categorizing of the variables. Whatever the list of variables, we try to get it as the first step in making or applying or getting this model in the data mining process. So we try to categorize the variables that have the relationship with one another. Okay. So that have the relationship with one another. And finally, we categorize the variables that are very much unique and distinct, and unrelated to the other variables. Excuse me. Unrelated to the other variables. So it is about the relationship I'm talking about. The relationship is about describing the significance, positive relationships, and the significant negative differences. Significant positive relationships and the significant negative relationships. So we need to understand still depth of it for the meaning of the relationship or correlation. Okay. So the first and the foremost measure of the strength of the relationship is only correlation. I'm just splitting. So I'm just splitting that word as cause, relation. Please try to understand that. Correlation. Actually, co-space relation, or we can call it as correlation. C-O-R-R-E, right? So correlation. So what is the strength or that the correlation is about? The strength of the correlation is, it is nothing but a quantitative measure. So it is a measuring parameter that is being used to measure the normalized range of values between 0 and 1. If correlation is 1, what it indicates. If the correlation is 0, what it indicates. If the correlation is less than 0, what it indicates. So we need to understand that like this. A correlation is 1. Let us understand there are a range of values. But when we are trying to see this quantitative measure that is being very much perfectly used to measure the normalized range between the 0 and 1, means that the values could be 0 or 1 or less than 0. Okay. Then the correlation of 1, if we assume that 1 is R value, then it indicates that the relationship is very perfect. Please underline and keep it in your mind. If the R is equal to 1, means the correlation value indicates as 1. If the correlation is 1, then it indicates that the relationship is very, very much perfect. Very much perfect. So what do you mean by that relationship perfect, ma'am? We said there are segregation of variables which we'll do after listing all the variables. So we try to establish the the dependent variables of the interest, and we also try to examine the possible relationships among the variables of the interest, wherein we try to get the independent variables also, isn't it? Okay. So when we get something like that, and I said that correlation 1 indicates perfect relationship where the two variables are very much perfectly synced to each other, or very much perfect sync is established. Then the other possibility of the R value, that is correlation value, is a 0. What does it mean? Automatically vice versa, right? We know Boolean values, true or false, right? 0 or 1, correct? Now 1 means perfect relationship, 0 means no perfect relationship or no relationship. Understand? Okay. A correlation 0 indicates that there is no relationship between the variable. Try to understand two possibilities. Within the normalized range between 0 and 1 for a correlation as a quantitative measure. So that is going to be measuring the normalized range of values 0 and 1. Okay. So if the correlation, the coefficient R, which is called as a correlation, is 1, then it is a perfect relationship where the two variables are in perfect sync. That is the meaning. Then the other possibility is a correlation is 0. The other possibility is correlation is 0. That indicates there is no relationship between the variable. Right? Now the question comes, ma'am, what could be less than 0? What could be more than 1? Means what is minus 1? What could be the possibility of measuring value for plus 1? Because the relationships can be positive, relationships can be negative. Relationships can be positive, relationships can be negative, isn't it? So the relationship can be positive or it can be of an inverse relationship, that is negative. I took it as a word negative, or it is called as an inverse relationship. That is, whenever the variable which we are trying to use it may move together to the same direction or towards the opposite direction. So towards the same direction means towards the positive relationship, opposite direction means negative relationship. So therefore, a very good measure of correlation, very good measure of correlation, 1 minute, very good measure of, give me a minute time. Okay. So we were talking about the relationship can be positive or can be inverse relationship. So that is, the variables may move together in the same direction or in the opposite direction. So therefore, what we have started understanding is a good measure of correlation is the correlation coefficient, which is the square root of the correlation. So this correlation is called as small r, Thus, it may be ranging between the value from -1 to +1, -1 to +1. But if the R value is 0, then it signifies that no relationships, what we understood just now. And if the R value indicates as 1, so that shows that there is a perfect relationship and there is a sync between the variables, which we are understanding that moving of the, it is trying to move in the same direction. It is going to move in the same direction. And there is one more possibility of the value, or can also have the -1. So that shows that the perfect relationship about moving in opposite direction. The perfect relationship moving out in the opposite direction. So let us take an example. Okay, so let me open up the whiteboard. Okay, so than the PPT, because now a little bit mathematical formulations we need to do it to understand this regression concept. Okay. Is the whiteboard visible to you? Is the whiteboard visible to you?
Yes, ma'am.
Okay. So let me clear off this. Otherwise,